Dames en here, die akademiese prosesie sal binnekort inbeweeg. U word versoek om asseblief op te staan.
Bomma le bontate, moloko-loko wa dirutegi o tla tsena mo nakong e kopana. Le kgopelwa go ema. Ladies and gentlemen, the academic procession will enter shortly. You're kindly requested to stand.
By the power vested in me, I hereby constitute this assembly as a legal congregation of the University of Pretoria. During this assembly, degrees with all the associated rights and privileges will be conferred on the candidates whose names appear in the program. Please be seated. Ladies and gentlemen, we request you to join us in silent prayer or meditation to give thanks for the achievements of our students. Thank you. Ladies and gentlemen, as Vice Principal of the University of Pretoria, I extend a very warm welcome to all of you this morning to this graduation ceremony. A special word of welcome to the recipient of our honorary doctorate this morning, Professor Robert Cooks. I also want to acknowledge the presence of the Acting Dean, Professor Maharaj, the Deputy Dean, Teaching and Learning, Professor Bloomer, the Deputy Director, Student Systems, Mr. Swanepoel, and then, of course, all chairpersons of school, all heads of departments, all directors, emeriti, honorary professors, and other lecturers and their spouses or partners. Also want to acknowledge the presence of the representative of the Student Representative Council, Mr. Motsa Motluutse, who will present the SRC academic honorary colors. And then, of course, the reason why we are here this morning, everyone who will be receiving a degree this morning. Also, a very warm welcome to your family, your spouses, your parents, as well as any other parties or dignitaries of whom we may not be aware of. I now request the Dean to introduce to me the candidate for the honorary doctorate.
Madam Vice Principal, I have the honor of introducing to you Professor Robert Graham Cooks for the conferment of the degree Doctor of Science Honoris Causa. Graham Cooks grew up on the South Coast and attended the Potchefstroom High School. He conducted research on natural products under Professor Frank Warren, then received an Elsie Ballot Scholarship to the Cambridge. There he worked with Professor Sykes of A Guidebook to Mechanisms in Organic Chemistry and Dudley Williams. Cooks is a pioneer in the conception and implementation of tandem mass spectrometry. This led to the construction of various mass spectrometers and their application to problems of trace chemical detection and intraoperative tissue diagnostics. He reported the first iron-soft landing experiments, landing organics and protein ions gently onto surfaces. He initiated the use of ions as reagents in chemical synthesis, running reactions at 1 per second and generating thousands of new compounds in a few hours. His methodology for chemically imaging fingerprints has been extended to molecular imaging in lipidomics and metabolomics. Cooks is a fellow of several US and Indian science academies and has had a long association with several Chinese universities. Some of his inventions have been commercialized through companies launched from his laboratory. He has served as a major professor to 159 doctoral students. More than 60 of his mentees hold faculty positions at universities worldwide. Madam Vice Principal, I request you to confer the honorary doctorate on the candidate.
I hereby confer the degree Doctorate of Science Honoris Causa on the candidate with all its associated rights and privileges. Congratulations. I have the honor of requesting Professor Robert Graham Cooks to address the Assembly.
Vice Principal Ferris, Dean Maharaj, members of the faculty, members of the public, and soon-to-be graduates, I'm obviously highly delighted to be here to receive this honor from this great university. I want to make just one other word of thanks, and that goes to Professor Rohr, and also in regard to all of the contributions that he's made to analytical chemistry over the years, and also to Professor Forbes, both of whom are here, and who highly deserve recognition, such as the one that I'm receiving today. So thank you very, very much. So to the soon-to-be graduates, soon-to-be, this is a wonderful time. Everybody that knows you is happy for you. People that don't know you are happy for you. You yourself, you're happy for you. I want to ask a question and put it in the context of running. And the question is this: What's the point of those people up ahead of you in the race? What are they doing? What have they done? What they've done is they've gone through the things that you're going to go through. They've experienced the problems that you'll experience. They've overcome the difficulties that you will surely overcome. And they've achieved the successes that you can expect also to achieve. And I make that comment because it's a nice, polite way of asking you to listen to me for a few minutes. What do I have to tell you? 3 things. Firstly, I want to tell you and seek your agreement that science is absolutely fascinating. If you didn't think that, you would probably not be here. The second thing I want to say is that I think that this is a singular day. Today is a singular day. I'll come back to number 2. And the third thing I want to say is there are lots of other things in life besides science. Those are the 3 little things I want to say. So the first one with regard to the fascination of science, what is it? It's really the surprises that come about in science. It's the unexpected things that make a difference, that draw our attention. Just thinking about things I've seen this last week, I'll add a couple of those to some items from earlier and just give you a number of different items. One item in the news, in the science news this week, 66-million-year-old dinosaur skeleton from which was extracted collagen, protein that can be sequenced. So we didn't have this last year. This year we have protein from dinosaurs, which means soon we'll have the genome of the dinosaur. Soon we'll be breeding them. Think of that. The article was titled Rocking Paleontology. Paleontology is all about rocks, and this was a rock from a dinosaur 66 million years ago, which was analyzed, and this was the result. Another article about Ethiopia, where there were 1.7 million years ago, rocks which contained hominoid fossils as well as some Australopithecus fossils. And the idea there was that these 2 species, that's our progenitors and the others, were living side by side. Another interesting item, tumor margins in brain cancer. Tumor margins. That's the most important information if you're attempting to treat brain cancer that you would possibly have. Hasn't been easily available, hasn't been accurately available. That's in the process. If I touch this lectern and you come by later, you can tell a couple of things. You can tell who touched the lectern at this position from my fingerprint, from my latent fingerprint. But you can do chemical analysis on that fingerprint at the same time, and you can say what I was handling earlier in the day. For example, if it were cocaine, it wasn't, but if it were cocaine, you could tell. That's pretty powerful. Chemical agents, Novichok, for example, well known from the poisoning case. Antidotes to that, novel drugs. And the last one, early detection of Parkinson's at a rate at which dogs can't even do it this quickly, just a sniff or 2 of a mass spectrometer. So those 6 items came from one area of science, and that area of science just happens to be the area in which I work, mass spectrometry, analytical chemistry. And that first item, the collagen protein in the dinosaur, that's a huge surprise, which came from a mass spec analysis. So all the areas of science have similar exciting things going on. Item 2, a singular time, singular day. So I want to take that apart a little bit, look at it, And maybe let's even model it. What do we mean by a singular day, a singular time? So we obviously, in making a model, need to have an x-axis and a y-axis at the very least. And the x-axis, if we're talking about a period of time, has got to be t for time. And we can make the origin the present moment, or the moment at which you will receive your degree. And we can have negative numbers going to the left and positive numbers going to the right. This is how we do it. What are we going to plot? We're going to plot the intensity of your emotion with regard to this event. So 2 weeks ago, you had no intense emotion. You didn't even know for sure you would be here. You were finishing exams, for example. Well, you're here, and so right now your emotion is a whole lot higher. And so let's use an equation, because we're scientists. And so some emotion quality factor Q is going to be equal to something. We make it up in science, and then we usually find out if it's right or not, and then we refine it. So it's the negative of the reciprocal of time, minus 1 over t, y equals minus 1 over x. So what does that look like? 2 weeks ago, that was very close to 0. A day ago, it was much, much higher. An hour ago, when you were driving here, it was pretty high. The intensity of the emotion, the anticipation factor that I'm talking about was high. And in a few minutes, when you receive your degree, it'll be off scale, because t will be 0, as we've defined it. The quality would be infinite. And a few seconds after you've had your degree, it'll go in the other direction, because now we're looking backwards. And so we've got an equation which goes zoop, and then it comes back down, zoop, and in both times it's gone to infinity. So that particular equation has a singularity at t equals 0, a singularity. Time disappears. As you get your degree, time stops. There's a pre and there's a post, and there's this stopped time. So the implications are amazing. The implications mean that we may even question the whole concept of time. There's implications in regard to cosmology, which people are already looking at. Is it a real thing? Is time actually real? T.S. Eliot, who was probably the most accomplished, best-known poet of the 20th century, he wrote, for example, The Waste Land, which was essentially the beginning of nihilism. But he wrote a later poem called Four Quartets, and he captured what I've just been talking about. What he said was, what we call the beginning is often the end, and to make an end is to make a beginning. The end is where we start from. And that really describes the academic journey, because you're making an end today and you're making a beginning. You're doing both of those things. So while I wish you passion for your career, your work in science, I also think it's very important, and this is my third and last item, that you have other things that you're passionate about and that are important to you. I was fortunate enough at Port Shepstone High School to have teachers who imbued an appreciation for literature in me. And so Dostoevsky means more to me than does dynamics, especially the dynamics. And Tennyson and Keats mean more to me than JACS and PNAS, which are the two journals that I'm supposed to be reading. And Saramago I take over synthesis, Ishiguro over integration, and Coetzee, the South African writer, Jan Coetzee, I take over chemistry. So I have some things that keep me going in the science, and they're not in science itself. And so what's your choice? I'm going to go through a little list, and I hope you can identify one or other item in this list or related to this list that'll be your non-scientific enthusiasm in life. The history of Pretoria, Oliver Tambo biography, poetry of Tennyson, wood carving, music of Brahms, scuba diving, competitive tennis, amateur microscopy, model railroads, rose gardening, Latin dance, volunteering in youth homes, running for city council, raising Yorkshire Terriers. So my wish for you is a combination of three things: your success in the scientific future, your recognition of the fact that there are other components to life that you should, for your own sake, give the maximum attention to, and the timelessness of this present day. I close again with T.S. Eliot and the Four Quartets. We shall not cease from exploration, and the end of all our exploring will be to arrive where we started and to know the place for the first time. That's been my experience, and it's my wish for you. Thank you.
Thank you, Professor Cooks, for sharing, I guess, your fascination of science and time, it seems, with us. And I am convinced that the graduates will take your wisdom to heart as they move from this day to the next. I now request the Dean to introduce to me the candidates present whose names appear in the program.
Madam Vice Principal, the supervisors will now introduce the doctoral candidates.
Madam Vice Principal, I introduce to you Nyongwaba Atiosi, who has complied with the requirements for the degree Philosophia Doctor with a thesis titled Improving Hyperspectral and Multispectral Remote Sensing of Soil Moisture by Accounting for the Influence of Clay Content, prepared under my supervision and with Professor Abel Ramiolo and Dr. Nobutle Majozi as co-supervisors. In this thesis, the candidate investigated how clay content and its interaction with soil moisture enhance soil moisture estimation using hyperspectral and multispectral remote sensing. The candidate developed an approach that predicts soil moisture content from a lookup table generated from simulated hyperspectral data and their corresponding moisture values. Thousands of representative South African soil spectra capturing the interactions between soil moisture and clay content were produced using a Monte Carlo simulation framework. Incorporating clay moisture interactions into the predictive models significantly improved soil moisture estimation and strengthened model transferability across both space and time. The approach also proved effective for estimating soil moisture under crop cover. This study advances remote sensing of soil moisture, a critical variable in precision agriculture and food production. Madam Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce to you Babatunde Awe, who has compiled with the requirements for the degree Philosophy Doctor with a thesis titled Synthesis and Applications of Ruthenium-2 Complexes, featuring ONO ligands prepared under my supervision and with Professor Landman as co-supervisor. In this thesis, the candidate achieved significant advances in the design of multifunctional ruthenium-2 complexes. The research introduced new pincer ligands capable of supporting both catalytic and biological activity within a single framework. By modulating the donor environment, the candidate established structure-property relationships that linked ligand architecture to catalytic efficiency and redox behavior. The complexes proved effective in catalytic hydrogenation and oxidation reactions and revealed reversible redox couples at low potentials. Selected compounds also exhibited cytotoxic activity against melanoma and macrophage cell lines, highlighting their potential as metallodrug precursors. Collectively, the study bridges homogeneous catalysis and medicinal inorganic chemistry, expanding the chemical space of pincer-type ruthenium systems and contributing original insight into the design of multifunctional metal complexes. Madam Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidates. Congratulations.
Madam Vice Principal, I introduce to you Ndiefatu Diop, who has complied with the requirements for the degree Doctor of Philosophy in Physics with thesis titled Eco-Friendly Synthesis and Characterization of Nickel-Cobalt Metal Organic Frameworks and their nickel-cobalt oxide derivative for supercapacitor applications, prepared under my supervision and co-supervision of Professor Balangom. The candidate investigated an environmentally friendly synthesis utilizing precipitation methods for MOFs and thermal treatment methods to produce nickel cobalt oxide. This work emphasized sustainable and efficient method for improving the electrochemical properties of incorporating single ligand, double ligand, and composite nickel oxide derived from nickel cobalt MOF. Benzene tricarboxylic acid was added to 2-methimazone, improving nickel cobalt MOF, which presented low electrical conductivity and sufficient stability. Additionally, the derivative nickel cobalt oxide was obtained by a novel thermal process with improved physical and chemical properties. Asymmetric supercapacitors were fabricated using optimized electrodes which exhibited excellent specific energy and power ranging from 29 to 39 watt-hour per kilogram and 413 to 613 watt per kilogram, respectively in a 6-mole aqueous electrolyte of 1.6 volts, demonstrating the potential as advanced electrode materials for high-performance supercapacitor applications. Madam Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce to you Unesa Doctorate, who has complied with the requirements for the degree Doctor of Philosophy, with a thesis titled Biomimetic Coating and Bioactivity Assessment on Appetite Coatings on Glassy Carbon and Titanium Aluminium Vanadium, prepared under my supervision and with Prof. Malhebe and Dr. Nzowane as co-supervisors. In this thesis, the candidate investigated how surface treatment influences appetite growth on biomedical substrates, specifically medical-grade titanium aluminum vanadium and glassy carbon. The substrate were immersed in simulated body fluid for 56 days under physiological conditions and subsequently characterized with multiple analytic techniques. The study showed that titanium aluminum vanadium supported highly crystalline, mechanically robust appetite coatings, with the sandblasted and plasma-etched surfaces achieving strong adhesion and elastic properties comparable to that of the cortical bone. By contrast, glassy carbon developed a more porous, calcium-rich appetite layers that enhance bioactivity and may improve bone bonding. These findings demonstrate that surface modification can be strategically applied to balance mechanical strength with biological performance, providing a framework for designing bioactive implant surfaces that unite long-term stability with improved osseointegration, thereby advancing orthopedic biomaterial technology. Madam Vice Principal, I request you to confer the degree to the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce you to Falokue, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled First Principle Study of Lithium and Sodium Oxide on Borofine Polymorphs for Efficient Energy Generation Metal Air Batteries, prepared under the supervision of our Dr. Refilwe Edwin Mapasha. In this thesis, the candidate developed quantum mechanical energy functionals and successfully integrated them into state-of-the-art density functional theory methods, as implemented in the Quantum Espresso Code. The code was used to study the energy stability, the structural integrity, and the electrochemical properties of profene polymorphs as potential cathode materials for lithium and sodium air batteries. The findings demonstrate that metal oxides absorbed on porofene do not readily dissociate into the electrolyte during electrochemical processes, and an effect attributed to their strong absorption on porofene surfaces. Furthermore, the study reveals that porofene systems possess high specific capacities, low open circuit voltages, and relatively low overpotentials, as determined from Gibbs free energy charges, key characteristics for high-performance metal air batteries. The candidate convincingly demonstrates the potential of porofenes as cathodes for energy next-generation metal air batteries. Madam Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce to you Bereket Tsahai Haile, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Sustainability Assessment of Horticultural Production Systems in Eritrea, a multidisciplinary analysis, prepared under the supervision of Professor Andy Dougal and Professor Abel Ramuelo as co-supervisors. In this thesis, the candidate presents an integrated multidisciplinary assessment of the sustainability of horticultural production systems in Eritrea. By combining remote sensing, participatory indicator development, and farm-level sustainability evaluation, the research offers one of the first comprehensive examinations of how environmental, economic, and social factors interact to shape horticultural performance in data-scarce regions. The candidate demonstrates that substantial expansion of irrigated agriculture does not automatically translate into improved yields, highlighting the critical roles of water availability and institutional support. Through a participatory process, the candidate co-developed a set of context-specific sustainability indicators and applied them across farming systems using econometric analysis. The results reveal that institutional factors, including training, cooperative membership, and extension services are key drivers of sustainable agricultural practices. The approaches developed in this thesis provide a replicable framework for sustainability assessment in low data countries, offering evidence-based insights essential for guiding policy. Madam Vice Principal, I request that you confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce to you Misha Malarbe, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Above and Below Ground Vegetation Characteristics in the Remnant Urban Grassland Patches of the City of Tshwane, prepared under my supervision and with Professor Peter Leroux as co-supervisor. In this thesis, the candidate examined how reserve size, connectivity, and finer scale topography influence plant species richness, abundance, and above and below ground similarity in Tshwane's grassland nature reserves. Results revealed high levels of alien plant invasion, both above and below ground, and low above and below ground similarity, suggesting limited natural regeneration potential from seed banks. The candidate further researched the influence of germination time on seedling emergence in a germination trial. As expected, longer duration increased species richness and abundance. However, these increases were not reserve-specific, suggesting that the outcomes of comparative studies should be largely unaffected by germination time. By advancing the understanding of vegetation characteristics in urban grasslands, this work highlights the role of seed banks in grassland resilience and underscores the importance of active restoration to enhance the long-term conservation value of these ecosystems. Madam Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce to you Mampo Maoe, who has complied with the requirements for the degree Philosophy Doctora for the thesis titled The Use of Infrared Thermography to Enhance the Characterization of Unsaturated Flow through Fractured Rock Mass, prepared under my supervision and the co-supervision of Professor Louis van Rooij. In this thesis, the candidate validated the use of infrared thermography as a powerful, non-invasive tool for detecting and characterizing groundwater seepage in fractured rock masses in an open pit environment, with direct implications for slope stability and dewatering management. By combining passive and active thermographic approaches with innovative post-processing techniques, including image difference methodologies, time-lapse sequence analysis, and cross-validation of the thermal signatures, the candidate demonstrated that seepage zones and hydraulically active fracture networks exhibit distinct thermal anomalies that are readily distinguishable from the widely varying ambient temperatures of dry rock surfaces across seasons. This thermal contrast enabled the mapping of previously undetectable preferential flow paths and interconnected discontinuities, even if high wall environments influenced by blast-induced fracturing. The work establishes a framework for integrating thermographic monitoring with rock mass characterization, providing a practical, real-time method for identifying zones of active groundwater inflow that may pose risk to slope stability. Madam Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce to you Nsovo Samuel Matibula, who has complied with the requirement for the degree Philosophy Doctor with a thesis titled The Interactions of Cholesterol with Mycolic Acid and Phosphatidylcholine Liposomal Membrane, and application to electrochemical sensing of tuberculosis and cholesterol, prepared under my supervision. In this thesis, the candidate explored the interactions among cholesterol, mycolic acid, and phosphatidylcholine using electrochemical experiments and computational calculations to enhance tuberculosis detection. A glassy carbon electrode modified with mycolic acid, constrained activated carbon, was developed as an electrochemical TB immunosensor. Results confirmed the existence of cross-reactivity between anti-cholesterol antibodies and mycolic acid antigens, which negatively impacts the detection specificity of tuberculosis. To mitigate this, a pre-incubation protocol involving liposomes has been found to improve the detection specificity. Computational calculations further revealed that cholesterol interacts more strongly with mycolic acid antigens than phosphatidylcholine, which is a spurious sensing platform for cholesterol detection. Electrochemical biosensor results validated the findings, demonstrating excellent detection limits. Overall, this study advances electrochemical biosensing for both tuberculosis and cholesterol detection. The results, the PhD resulted in patents, international patents, and peer-reviewed publications. Madam Vice Principal, I request you to confer the degree on the candidates.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce to you Amos Ramatlodi Kialeboka Mosupi, who has complied with the requirements for the degree Philosophia Doctor, with a thesis titled Facile Synthesis of Ion-Based Metal Organic Frameworks and Carbon Derivatives via unconventional precursors for gas storage applications. Prepared under my supervision and with Prof. N.M. Misioka as co-supervisor. In this thesis, the candidate synthesized ion-based metal organic frameworks, also known as MOFs, via underexplored unconventional approaches and precursors as potential gas storage materials. Traditional routes for preparing these materials are often costly. This study explored unconventional methods which are quick, environmentally friendly, and cost-effective. A key innovation in this work was the successful use of sonochemical-assisted synthesis, a relatively underexplored method for the synthesis of ion-based MOFs. This method relies on sound and vibration to initiate and accelerate chemical reactions, thus reducing synthesis time and energy consumption. Additionally, the candidate explored the use of major pollutants, i.e., acid mine drainage, which is rich in dissolved metals, and waste plastic, as sustainable, low-cost precursors for MOF synthesis. Overall, this body of work presents a compelling case for the cost-effective, sustainable industrial synthesis of ion-based MOFs. It further supports environmental remediation and the circular economy. Madam Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce to you Thandeka Vumile Ndlela, who has complied with the requirements for the degree Philosophy Doctor, with a thesis entitled Peatland Functioning under Contrasting Management Systems in Eswatini, the Consequential Impacts on Hydrology, Greenhouse Gas Flux, and peatland properties, prepared under my supervision. In this thesis, the candidate compared a protected peatland with a community-managed peatland to examine how management practices influence peatland functioning. By combining long-term climate analysis, eco-hydrological monitoring, peat soil characterization, and greenhouse gas flux measurements, The research provides a first detailed study of peatlands in Eswatini. It further contributes rare empirical evidence for peatland genesis and management in the wider Southern African region, in that the research demonstrates that the protected peatland has maintained a stable hydrology, intact peat layers, and relatively stable methane fluxes. By contrast, the community-managed site exhibits hydrological stress, peatland degradation, and irregular flux patterns, primarily linked to drainage channels and livestock grazing. These insights advance understanding of how climate variability and human activities interact to influence peatland dynamics and their carbon storage capacity, providing a critical evidence base to guide conservation, restoration, and policy efforts across Southern Africa. The research has provided 5 conference papers at national and international level and has formed the basis for 4 acclaimed publications to date. Madam Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce to you Langanani Rakunwana, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Supporting First-Year Teaching and Learning of Electrochemistry, prepared under my supervision and with Prof. Elizabeth Mavunga as co-supervisor. In the thesis, the candidate investigated how first-year electrochemistry was taught by analyzing lecturers' enacted topic-specific pedagogical content knowledge, or TSPCK. Data collected included classroom observations, teaching materials, and interviews with the lecturers. The study demonstrates differences in the sophistication of the lecturers' enacted TSPCK and identifies concepts within the electrochemistry topic where pedagogical support was limited. Based on these diagnostics, the candidate developed and implemented an intervention called Chem Organizers to support students. The Chem Organizers presented complex electrochemistry content in a more accessible manner for the students. The intervention led to significant improvement in students' understanding of electrochemistry across 2 student cohorts. Overall, the candidate provides a diagnostic approach for analyzing teaching and demonstrates how TSPCK-informed insights could effectively guide evidence-based interventions in chemistry education. Madam Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce to you Precious Katleiko Sajake, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Identifying High Redshift Radio Galaxies in the Gleam-Fojansky Sample, prepared under the supervision of Dr. Sarah White and mine. In this thesis, identifying high redshift radio galaxies in the Gleam-Fojansky sample, the candidate investigated the optical spectra of powerful radio galaxies, primarily in the southern sky, to facilitate detailed explorations of the astrophysics of these cosmologically vital objects. Using multi-wavelength observations, including data from key facilities such as the Meerkat in South Africa and ASCAP in Australia, both precursor instruments of the upcoming Square Kilometre Array, the Very Large Array in the United States, and the optical spectroscopy from the Southern African Large Telescope. The candidate analyzed the properties of radio-loud active galactic nuclei and expanded the redshift information available for the Gleam-Fojansky sample of radio galaxies. Their work enabled spectroscopic redshifts for 147 Gleam-Fojansky radio galaxies and provided pathways to understanding the evolution of powerful radio galaxies. It enhances the scientific legacy of current and future large area radio surveys carried out in the southern skies. Madam Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce to you Sizwe Bekitemba Sibia, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Towards Stable and Improved Performance of All Inorganic Cesium-Based Solar Cells, prepared under my supervision. In this thesis, the candidate developed scalable deposition and interface engineering strategies to advance the performance, stability, and manufacturability of all inorganic cesium-lead iodide perovskite solar cells by integrating sequential physical vapor deposition, spray pyrolysis, and solvent-free surface passivation. The body of work represents a significant advance in controlling crystallinity, defect density, and interfacial charge transport in vacuum-processed perovskite devices. The candidate demonstrated that high-quality gamma cesium lead iodide thin films with enhanced phase stability and optoelectronic properties can be reproducibly achieved, enabling enhanced charge extraction and competitive power conversion efficiencies. The approaches developed in this thesis provide a robust foundation for tandem-compatible, industrially scalable, and environmentally stable inorganic perovskite photovoltaic technologies. This work contributes insight relevant to the future commercial deployment of perovskite solar cell as an alternative for clean and renewable energy supply. Madam Vice Principal, I request that you confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce to you Sabelo Petro Semelane, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Land Use and Land Cover Change in Mbabane City, Eswatini, using remote sensing and machine learning to support sustainable development goals, prepared under my supervision and with Prof. George Chirima and Dr. Silence Mungamezulu of the Agricultural Research Council as co-supervisors. In his thesis, the candidate developed a scalable, data-driven methodological framework for high-accuracy land use and land cover mapping and the computation of SDG Indicator 11.3.1, land consumption rates to population growth rates in Eswatini and similar sub-Saharan African context. By integrating open-access medium-resolution satellite imagery such as Landsat and data enhancement techniques such as simple layer stacking and principal component analysis, and a custom ensemble machine learning classifier, the work achieved an overall accuracy of 98%. This approach successfully addressed critical data gaps by accurately mapping built-up areas for Mbabane City from 1997 to 2017. The candidate's findings, which showed a change of 1.3, highlighted unsustainable urban expansion and provide a robust, politically relevant foundation for evidence-based urban governments and sustainable planning. The framework is replicable and offers a significant advance for monitoring the SDGs in resource-constrained environments. Madam Vice Principal, I request you confer the degree on the candidates.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I introduce to you Solomane Theo, who has complied with requirements for the degree of Doctor of Philosophy, with the thesis titled Optimized Mixture of Water in Salt and Ionic Liquid Electrolytes for High-Performance Supercapacitors, prepared under my supervision and co-supervision of Professor Balangom. The candidate achieved major advances in the development of hybrid electrolytes for next-generation aqueous supercapacitors. A novel electrolyte system was formulated by combining a concentrated sodium nitrate water in salt solution with ionic liquid MIM DACA to refine sulfation structures, suppress water activity, and enhance ion transport. When coupled with nitrogen and sulfur-doped carbons derived from mangosteen shell waste, the optimized system exhibits a widened voltage window of 2 volts, a specific capacitance of 257 farad per gram, an energy density of 50 watt per kilogram, and power density of 583 watt per kilogram, with outstanding cycle stability. This research provides new insight into fundamental relationship between electrolyte composition and electrochemical performance. The outcomes demonstrate a sustainable and scalable approach to overcoming voltage limitations in aqueous systems, paving the way for high-performance, durable, and environmentally responsible energy storage technologies. Madam Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, I present to you Lorinda Tereen van Wyk for the degree, who has complied with the requirements for the degree Philosophy Doctor with a thesis entitled Advancing Small Organic Molecule Synthesis, Integrating Additive Manufacturing and Flow Chemistry Techniques under my supervision and with Professor Dr. Jenny Panadides as co-supervisor. In this thesis, the candidate developed novel reactor technologies to advance the field of flow chemistry by leveraging additive manufacturing and subtractive manufacturing techniques. By creating innovative reactor designs, including a hybrid manufactured screw reactor and a chemical-resistant peak settler filter, the candidate successfully improved the handling of particulates under continuous flow conditions. The candidate also developed safer, greener, and significantly more efficient continuous flow synthetic processes towards active pharmaceutical ingredients, specifically bupropion and fluoxetine hydrochloride, outperforming traditional batch counterparts. Finally, a specialized additive manufacturer, a microflow reactor tailored for photochemical applications under flow conditions, was also designed and prototyped. Together, these contributions represent a significant advancement in integrating flow chemistry and modern manufacturing approaches. Madam Vice Principal, I request that you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Madam Vice Principal, the following candidates have complied with all the requirements for the degree Master of Science specializing in chemistry. Serena Yobert. Ntoko Liakwe. Specializing in environmental management, Gabrielle Krobler, with distinction. Simone Creel, with distinction. Nomsa Mutelo. Specializing in geography and environmental science, Sishle Nslapo. Specializing in geoinformatics, Tilly Pasla. Magdalene Purchase. Theo Suaneng. Specializing in geology, Chanel Duplessis. Ndo Duzo Gumede. Kotsiane Bochabi. Specializing in hydrogeology, Jordan Young. Specializing in meteorology, Jessica van der Westhuizen. Specializing in physics, Sarah Burnett with distinction. Rifumo Chwaka with distinction. Basia Mahapane. Madam Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science Honours in Chemistry, Lorato Tlamini. Lorraine Gravenstein. Annelien Hrobler. Kyle Hrobler with distinction. Boiketlo Slabane. Boiketlo also receives the Brooker Award or prize for the best student in physical chemistry for the degree BSc Honours. Princess Koza. Brendan Kruger. Sunay Martins. Morgan Payne. In engineering and environmental geology, Esther Okamp. Tumelo Kwabane. James Leroux with distinction. Kayuri Mudley. Tabang Poza. Milena Plesik with distinction. Kayla Thompson with distinction. Armand van der Linde. Dayton van der Wissel. Johan Vermaak with distinction. Tariq Walker with distinction. In geoinformatics, Melakushle Juma. Coriane Erasmus. Tando Konene. Mama Marakabesi with distinction. Morateng Moripane. Asa Moifo. Lunamandla Mapeleni. Leah Ruam with distinction. In geology, Natasha Dutoy with distinction. Charles Hopley with distinction. Aaron Hughes. Eli Louis. Kimberly Lukeshle. Maputi Mabalane with distinction. Zifo Mashlangu. Koena Mapepa. Nsako Matibela. Eneto Ndaka. Mtlatla Khonolo Monkwetsi. Ntalala Nslangwini. Khonse Polane. Liam Roberts. Faith van Wyk. In meteorology, Tinotenda Shinoro. S.T. Hay with distinction. Rita Lowan with distinction. Nkosi Nkobise Mabuisa. Lulama Nkobozi. Martinez Pretorius. Ikaneng Siashala with distinction. Yarushka Singh. In physics, Lawrence Bosman with distinction. Johannes de Lange with distinction. Conrad Foloshi. Jordan Green. Amisha Ranchod. Muhammad Rasul. Gabriel Richard with distinction. Kutlahano Sikosana. Madam Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science, Honours in Geography. Gemma Hickenbotham with distinction. Tiara Kamadu. Erica LaRue with distinction. Alizwa Matinjua. Kapano Morisane. Kyle Tiron with distinction. Sunay van die Kerk. Madam Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science in Chemistry. Azra Adam. Mignon Botma with distinction. Apiwe Dlamini. Abigail Gallus. Kira Hakema with distinction. Marco Yu with distinction. Ongama Mantinshana. Paul Mankis. Bianca Perumal. Maslako Pecha. Luan Pojita. Katharina Simon. Camogelo Semenya. Vian van der Walt. Ryan van die Kerk. Simon van Zeel. Chelsea Wanyanya. Mslatli Zatuta. In Environmental and Engineering Geology, Netanya Becker with distinction. Netanya also receives the Rolf van der Merwe Prize for the best student in structural geology on third-year level only if a distinction was achieved in the module. Keola Yonka. In geology, CJ Becker. Devanya Bunjun. Soren Green. Jolene Kralen. Inge Groenewald. Slotslanang Montoshi. Mamararaka Nkuna. Anton Paulson with distinction. Nsako Pasha. Kagiso Sekwe. Tapelo Sikosana. Tari Sinovich. Reinhard Stead. Marco Statler. Shanice Tambala. Khotiso Chale. Retabile Vuma. In meteorology, Aryan Jainarayan. Aryan also receives the Johan and Sophie van Heerden Floating Trophy for the student who achieved the highest average mark in meteorology modules at the levels 2 and 3, as well as passed all the third-year modules within a period of 1 year. Emir Kutsir. Homelang Mabocha. Anika Meyer. Malepe Pasha. Sibonka Ka Nkonke, Shabangu. In physics, Shawnee Anderson with distinction. Shawnee also received the Analytical Chemistry Student Achiever Award for the best student in analytical chemistry at third year level. Charles Evenant. Bonga Kwela. Michaela Liebenberg. Kayla Lloyd. Max Melville. Jason Muldery. Almarie Mayberg. Kavir Nagesar. Amila Nachi. Jonathan Raghu. Amanda Retief. Mojalefa Sitiro. Stephen Sinclair with distinction. Parens Jennekamp with distinction. Insi Kalelo Shangalela. Piet Fosler. Sebastian Walters Sommers. Jessica Wells. Madam Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science in Geography. Nicole Baker. Tebogo Popape. Tian Kutsia. Jonathan Davies with distinction. Bernice de Beer. Sachita Devanuthan. Ntokozo Tlamini. Lisa Free. Erin Gallagher. Angela Jones. Pancho Lahari. Nienke Liebenbach. Mamule Mabunda. Letabo Makayisia. Sehorane Maila. Joshua Mayer. Rory Sang Monkhe Khelwa. Seshlansla Matwetwa. Amir Sali. Nikiwe Tabete. Elias Teka. Janet Schutter. Andre Fisser. Cameron Fisser. Anye Weidemann. Mduzi Yende. Madam Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science in Geoinformatics. Talisha Chetty. Silendile Tlamini. Lempile Ditsele. Iviwe Kuchana. Nsako Slanyeke. Robin Hockey with distinction. Emishle Mamadisa. Gundo Machado. Fidel Mbambo. Taboho Mota. Susan Mura Nzikwa. Lungusani Nyeke. Nicolene Prensler. Oratile Rantayo. Sarah Ryan. Offensa Sebulela. Namfundo Zakhali.
Can I also ask all of the graduates to please rise? Let's give them an applause. Thank you. Thank you. Now, graduates, here are all the people who supported you to get to this moment. Please turn to them and you give them an applause. And then last but not least, behind me on the podium are some of the lecturers who walked this journey with them, with you. So please turn to them and also applaud them. Thank you. We've now come to the end of the proceedings, but before we close, I would like to invite all of you present here for liquid refreshments afterwards in the marquee outside in front of the Rembrandt Hall. You are requested to stand for the singing of the national anthem and to remain standing until the assembly has been dissolved and the academic procession has left the auditorium. The words of the national anthem will appear on the screens. Please rise. By the power vested in me, I hereby dissolve this assembly of the University of Pretoria.
Sure! The graduates have spoken. Let's give them what they want. Graduates, uncommon and more graduates. So, I'm not and take it, Sanamare. Not and take it, Sanamare. Not and take it, Sanamare.